Hi. Now that you have a good understanding of what LCA is and how the LCA framework is used, we can look at how it is applied to circular products. Very exciting. Adjusting your model to represent a circular product should be done at the goal and scope and inventory stages, preferably in your first iteration before we apply the impact assessment. Of course, we can always readjust the model in the latter or later iterations. Therefore, when we model a circular product, we build the model accordingly in our inventory. Our process flow diagram can help us to identify the parts of our product life cycle where our product requires maintenance, where it is refurbished, or where the materials are recuperated or recycled. From here, it may be necessary to allocate flows from unit processes. Allocation can be defined as the partitioning of flows of a process to the product system under study. To understand when allocation is necessary, we need to define three key terms in the context of lifecycle inventory. Firstly, co-production. Secondly, combined waste treatment. And thirdly, recycling. Co-production or co-products are products other than the product we are studying, which are produced by processes in our product lifecycle. These other products do not contribute to the functional unit we have chosen and are outside our system boundary. For example, in the production of the plastic bread bag, we have a refinery process which produces kerosene. The kerosene is a product of value which leaves our product system, since it does not contribute to the functional unit and reference flow. It is a co-product. Now, you might be wondering how we divide the flows from the refinery process between the naphtha and the kerosene, which is part of another product system. This is where allocation becomes important. Allocation can also be used in other parts of our product system. When we have combined waste treatment, such as incineration, the incineration process destroys many different kinds of waste materials together, and not only the waste from our particular product processes. The flows from the combined waste treatment also need to be divided or partitioned between the wastes from our product system and the wastes from other product systems. When we process waste and are able to recuperate materials or recycle worthless material, then we also need to determine the extent to which the flows are partitioned. Processes prior and or after the recycling processes are partitioned between the prior product system and the latter product system. Let's look at the example of using waste wood in our refinery processes. Should the emissions and resources used in transporting the wood to the refinery be part of the previous product system? Or should they be part or be accounted for in our plastic bread bag example? And if we divide the impact, then what percentage of the emissions and resources used in our plastic bread bag are we accountable for? In this case, we also need an allocation procedure. There are different schools of thought when it comes to how allocation ought to be applied. In terms of the ISO rules, which you will encounter as an LCA practitioner in the circular economy, allocation should first be avoided as far as possible by making unit processes more detailed and adjusting the product system boundary. If partitioning is still required between processes, allocation can be based on economic value, mass, volume, or even energy content. Allocation is particularly important when we start to close material loops and go from products that are more or less cradle to grave to products that are cradle to cradle. Are you curious to learn how allocation is applied to co-products and recycling? See you next time.